Welcome back to part 2 of our live training session here using our Link G4x on our Honda K-Series engine. Now we're going to be taking a look in this tutorial at finishing up our base map creation process, building out all the 2-dimensional and 3-dimensional tables that we have to work with within our calibration file. Without further wait, let's jump in so we can check this out.
Welcome back to our live training session. We're going to be completing our base map creation process in this tutorial. The last tutorial we went through setting up our basic background details, setting up our inputs and outputs. Now we're going to be taking a look at setting up our 2-dimensional and 3-dimensional tables, such as our volumetric efficiency table, our spark timing table, our variable cam control table. We're going to be doing this very specifically so that we're going in and having a table that represents low and high cam or non-VTEC and VTEC of operation. This is exactly how Honda goes in and calibrates with the factory ECU. We want to mimic that to give the best drivability and the most repeatable and consistent power output from our Honda K-Series engine. Let's jump in and take a look at how we can accomplish this. So the very first thing, we're going to be going in here in the offline mode to make our editing changes to the base calibration file that we started with in that last tutorial. We've saved that file as base cal and we've created a new project folder labeled EP3 ITB K24. So the file is base cal saved into that folder. We're going to be using this again as our reference point for the start of this tutorial. So you definitely want to watch the last one to make sure you've configured all of the setting details for an alpha end strategy for doing our tuning process. Now, let's jump in here and take a look at where we're at and what we need to accomplish and calibrate here. So the first thing we're going to do is start off over here in our fuel tab. Now the layout that I'm working with is available in our training course folder under the link course packet. You want to go ahead and load that layout. That's what I'm working with, you see on screen here, using layout, load layout, and select the layout that we're working with. So in this case, we already have that loaded in here, and I don't need to go ahead and load that, but that's the exact process, bringing in that layout that I provide in the training course folder. Okay, so we have our tabs here. Essentially, we went through basics, cam crank, analog inputs, digital inputs, and outputs. We didn't do anything with CAN bus, and we're not doing anything with the mixture right now. Fuel is going to be where we start off. We're going to go from fuel and go across. Now we have a lot of different tabs here to do a lot of different tuning process and setup. Now in this case, we're not doing launch control. We're not going to be doing traction control. We're not doing drive-by-wire. We're not doing boost control. So a lot of these windows aren't going to be used. We're just primarily focused here on setting up the base map for this naturally aspirated alpha end strategy. So that leads us in here to our fuel page. Now, when we're talking about our fuel page, this table here is our volumetric efficiency table in our model mode. This represents the air mass that we're bringing into our engine, or essentially simulating to the link as what the air mass is bringing into the engine. This represents a percentage of cylinder filling, which is used in our air mass model, which is used to determine a fuel mass, and that gets converted into an injector pulse width, knowing our injector flow and our injector dead time and short pulse width table values. And that's what primarily is going to drive the fueling into the engine, and we want to be able to calibrate and do everything properly here for alpha end strategy. So the first thing we're going to find within looking at our VE table here is we need to go and review the breakpoints that we're dealing with in this table. So that's going to be our RPM breakpoints. We also need to deal with what we have as our load input to the table here. So we can see under the fuel table 1, MGP is what we're using for the load input. Now this is going to be the ratio between the baro and the map pressure. This allows us to constantly recalculate a proper VE and proper fueling amount as our elevation changes. Now, with an alpha end strategy, with an unstable map pressure signal, I went into the basics, we go back in here, and I've set the equation load source as load equals baro pressure. This is going to be something that we normally don't need to do, but with individual throttle bodies, especially huge individual throttle bodies with an unstable map pressure signal, we do have to select baro pressure as our equation source. So this is going to be redefining and recalculating things a bit different on our air mass modeling side. We jump back in here. When we select load equals baro, we need to go into the table for our alpha end strategy and select our unit scale for our table based on throttle position, or TP main, not based on MGP. So we need to do some reconfiguration here to get things right. So the engine RPM, let's just talk about that real quick. 8,500 is what our fuel table 1 here is going to go out to. That's sufficient because we're going to be treating our fuel table 1 as our low cam or non-VTEC operation table. This is going to be what's used to characterize the airflow that we're essentially simulating the airflow that's coming into the engine through this table values here. This is going to be what we use to characterize our low cam airflow model. So 8,500 is fine. I don't plan actually revving the engine much past 7,000. If we do go past 7,000, you can get rocker float because the VTEC pin isn't locked. So long term, it can create some rocker damage. We don't want to do that, but I do want to have some breakpoints here, a little bit higher than I anticipate revving the engine to on the low cam. So even 8,000 would be sufficient. We could update the table real quick. If we click on our axes and click X, and we jump over here, we can simply just deselect 8,500, get rid of that. So now that we're in our table axes setup, this allows us to go in here and change up our y-axis. We don't want it based on MGP, we want it based on throttle position. So if we go in here to the icon, we can click on this. This allows us to select a new input for the load source for our table. If I type in here TPS, give us a second, it's going to pull up all the different options. We want TPS main. This is going to be taking a look at our throttle position sensor, and there's a main and a sub. That's for drive-by-wire. So main and sub are the two TPS sensors for drive-by-wire. When we're dealing with a cable cable throttle body or individual throttle bodies, I have a cable style setup here. We're going to select our TPS main. So we're going to go ahead and select TPS main, and we'll just click Initialize Axes. This is going to put some generic breakpoints in our table. Now, what we're going to do here is be very specific of how we set our breakpoints up. We need to have very fine breakpoints between 0 and about 12% throttle. Because as we're going in and giving it throttle input, the very small tip-in of throttle movement on big throttle bodies allows a pretty large airflow surge coming into the engine, especially at low engine speeds. So we need to be able to characterize that properly and give an adequate resolution in our table. We want to go and set up our breakpoint axes very specifically. Let me go in and demonstrate this real quick. We're going to go ahead and we can see that it's going in 10% changes in our throttle. We're going to have a value at 0, then we'll have one at 1, and then we can put a value here at 3, then one at 5, and then we'll do one here at 7, then one at 9, and then we'll do one at 12, and we can do one at 15. Now let's go back and review here real quick. We can start to delete some things that we don't need. So we can find our breakpoint axes are going to start at 0, 1, 3, 5, 7, 9, and then we have a breakpoint at 10. Let's get rid of that. We can jump to 12, then 15. Then we can go from 15 to 20. We can get rid of a breakpoint at 30. So we'll find as we start to give it some more throttle input, the difference in airflow coming into our engine isn't as drastic. So we don't need as much resolution in the table once we get above about 20-25% throttle. So I'm going to go here at 20.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.